Good evening, guys. We are Group 9, and my name is Nathaniel, and I'm the group leader. So today we are presenting on the question that states that the speed of the data path cycle significantly affects the overall performance of the CPU. The faster the cycle, the quicker the CPU can execute instructions. And we as a group have basic objectives we want to achieve when whoever is watching this video is done watching the video. So we'll, by the end of this video, we will expect that whoever watches it is going to understand what the data path cycle is, and then some of its relevance in computer architecture, and then how the data path cycle affects the CPU's performance. So we are going to start by explaining what the data path cycle is, because when you tell someone what is data path cycle, the person is going to ask what is the data path cycle. So firstly, the data path cycle, or the fetch, decode and execute cycle, is a fundamental concept which describes the sequence of steps a computer's processor follows to execute a simple instruction or to perform a function. So with this definition, we have derived that the data path cycle can also be known as the fetch, decode and then execute cycle. So we can say the FDE cycle, this is known as the fetch, decode and execute. Then the data path cycle. So we'll be using them interchangeably so that we get familiar with them. And then we can also say that it is from this definition that the CPU is able to decode, or it is through this definition we can get to finalize that the CPU is some of the functions which the CPU performs as a result of the data path cycle. So let's take this for an example. An ATM machine. Yeah, when you get an ATM machine, the first thing you do, or the first thing which is displayed, is that you insert your card. So when you insert your card, we see that you are being asked for your PIN. When you put your PIN, then you get to select options on how much you want to withdraw. After that, you are being given your card back. A receipt is being printed for you, and then your money counts, and then you withdraw your money. So we can take the ATM machine as a data path cycle, whereby since it's a cycle, it repeats the same processes day in and day out. So as long as a computer system is in use, that is it for the ATM. So as long as the ATM is in use, it performs the same function every day. So when a different person comes, it's still that the same thing. Your card, your PIN, how much you want to withdraw, a receipt, you take your card back, and then your money is being given out to you. So we can conclude that the data path cycle is repetitive. I hope you are with me. So nextly, we would like to look at the fetch, decode and execute concept under the data path cycle. But before that, let us keep this in mind that the CPU consists of two parts, which is the arithmetic logic unit and then the control unit. And then the control unit consists of buses, which is we have the control bus, and then we have the data bus, then we have the arithmetic logic unit. I will further touch on what those do, but not extensively for the purpose of this presentation. Yeah. The fetch, decode and execute cycle, or concept, which previously we know as the data path cycle, which we have explained or defined. Now we are moving on to the fetch, decode and execute concept. So we'll pick it one by one. So firstly, it's fetch. So basically, when we say fetch, it means to get something, or to acquire something, or to retrieve something, or to take something from somewhere. So in this concept, when we say fetch, so the fetch is whereby the CPU, through the data path cycle, is able to retrieve information and instructions from the memory. Right. Now someone might ask, from which memory? Okay, so we have something called in computer architecture, we have something called data registers. These registers can serve as a memory, and then these registers serves as memory to whatever data is being keyed into the computer system. And we must also keep in mind that the registers are mostly found in the ALU. So typically for any random system, a register can contain up to 32 bits. Yes, 32 bits. It depending on the type of computer you're using, but mostly it's most computers have a 32-bit data register. So the CPU goes into the memory, which is the data, which is the register, where the register keeps memory instructions. So the CPU goes there to retrieve that instruction. So that is what is defined as the fetch concept. So with the fetch concept, once you've given your system a command, the CPU takes that command, right, and then enters the memory to fetch or to retrieve, and then it is being then the CPU acts on that. So for example, we can use our daily lives as an example. So if a lecturer comes to class, and then comes and teach we the students, and then gives us slides, So mostly as a rational student or as a random student, I can't mostly remember whatever the lecturer tells me. Therefore, I refer to the slides. So in this scenario, the slides become our register. So it keeps most of the things which cannot be easily remembered by the CPU. So therefore the CPU then tends or refers or relies on the memory, right, on the memory or the register to retrieve that back. So when it retrieves that, it's going to act on it. That's the fetch, or that's the fetch concept of the data path cycle. That's the first stage in the data path cycle. With the fetch concept, we can conclude that the memory address register takes data, or makes the CPU take data from the memory data register. So the memory address register helps the CPU retrieve data or information from the memory data register to Charlie, oh my god. Repeat. The memory address register takes data from the memory data register to the CPU from the RAM. So all this is definitely found within a computer system. Now we move on to the decode concept. So simply put, the decode concept is whereby after retrieving data after retrieving instructions from the memory data register through the data path. So firstly, the data path is simply should I say a passage whereby data retrieved is it passes through to the CPU. Yes, where data retrieved passes through to the CPU. That is the data path. So with the decode concept, we can say that with the decode concept, we are saying that after retrieval, the CPU is able to break whatever it has retrieved, is able to break down or decode, but simply put, decode. So the CPU is able to decode or break down whatever data or whatever instructions it has retrieved from the memory data register, and then determines what operation needs to be performed. So simply put, with our ATM scenario, right, when the ATM retrieves your pin, that is when you key in your pin, and then the system identifies that it is you, then so it is based on the option that the user select, that the ATM is able to determine what operation to run, whether you are checking your balance, or whether you are withdrawing money from your savings account or from your current account. So in relation to the CPU is able to determine whether you, the user, or the CPU is able to after retrieval, it is true that the code concept that the CPU will determine what the instructions retrieved are going to perform. Moving on. So in totality, we are saying that the code concept simply put, after retrieval of the data from the memory data register, determines whatever data is being retrieved is going to use for. Now to the final concept, which is the execute. Finally, the execute command, or the execute stage of the cycle. So the execute stage is whereby the processor after fetching and decoding is going to act based on whatever operations has been laid out in the instructions. So if you quite remember, in the decode concept, it said that it is where whatever has been retrieved is going to be decided on what is going to be used for. But in the execution, that in the execution stage, that has been done. So in the execution stage is we are going to see whatever data has been retrieved, what that data does, or the outcome or the output of that data. That is what the execution, or that's what the execute concept stands there for. So with the ATM scenario, when you select or when you key in the amount you want to withdraw from the ATM, that the decision has been made. So it is the job of the ATM to fulfill that to fulfill that duty, or to execute the choice you have made, which is what the withdrawal of the money you are taking. So let's say you have keyed in that you are withdrawing 500 cedis from the ATM. So once the ATM is known or has been made known of your choice, and then of what you want it to do, it is going to execute that. It's going to carry out that by what? Making you receive exactly 500 cedis. So with the execute command, the CPU is going to give you what you have requested, not what you have not requested. Or it's not going to give you it's not going to give you data. It's not going to carry out data in fractions, or it's not going to carry out or it's not going to display incomplete data, or it's not going to carry, or it's not going to act based on incomplete instructions. So it's going to give you what you have told it to do. Right. So in conclusion to the fetch, decode, and execute concept, we have to we can conclude, or we have to know that all this is done, or the rate at which data flows from the memory data register to the CPU for us to enjoy whatever we do with our computer system, all that is being monitored by the control bus. And earlier on, I made mention that the CPU is divided into two, which is the control unit and the arithmetic logic unit, of which the control unit consists of both the control bus and the data bus. So therefore, of which the control unit consists of a bus, and that bus is further divided into two, which is the control bus and the data bus. Therefore, the control bus is in charge of the data flow within the data path cycle. So how data flows within the cycle is being controlled and monitored, or is being regulated by the control bus. So we move on to the sub-second part of this presentation, which is the relevance, or the relevance of the data path cycle. So firstly, we are saying performance optimization. So the data path cycle helps computer architects to be able to plan well in order for your computer system to work thoroughly. So it is through the data path cycle that computer architects are able to determine how to optimize a computer system very well. So as the question said earlier on, the faster the cycle, the faster executions can be executed. So therefore, if the data path cycle stalls, or if the data path cycle has many problems with it, then it means that performance optimization of a system cannot be achieved, so making computer architects fail at their work. But therefore if the CPU is able to execute instructions efficiently, then it means that performance is optimized. It means that performance is good, performance is high. If the CPU can execute instructions fast, it means the performance of the system is fast. So therefore we can conclude that it is through execution that performance of a computer system can be achieved or derived. And one final significance is instruction level parallelism. So when we talk of parallelism, is whereby things can occur simultaneously, right? Or simultaneously, or at once, or at a go. So therefore, the data path cycle helps computer architects to design systems which can include or which can encompass instruction level parallelism. So this is whereby data instructions can be executed or can be taken at a go. Instruction level parallelism. So therefore we are saying that it is through the data path cycle that or the data path cycle the data path cycles allows instruction level parallelism to go on. So let's assume that instruction level was based on series. So this is whereby the data path cycle is going to let the CPU process data or execute data one at a time, which can delay time, or which can make time delay depending on whoever is using it or whatever that computer system is used for. But through the data path cycle, as time goes on, that it is being enhanced day in day out as technology advances, parallelism is being included in most computer systems. So therefore CPUs can execute multiple instructions at a go, and this helps to save time and then reduce delay in activities. So move on to the final part of today's video presentation, which is our final objective, which is making us understand how the data cycle affects the performance of the CPU. So first, we are saying that the CPU's performance in relation to the data path cycle is basically proven through its speed. So we are saying that when the CPU is fast, the more the data path cycle helps the CPU to execute more instructions, which will lead to a better performance or to an optimized and enhanced performance of a computer system. So we are taking into consideration the length of the data path cycle. So we are saying that the longer the data path cycle, it means that we are saying that the longer the data path cycle, the fewer commands can be or instructions can be executed. But the shorter it is, the more commands can be executed. So let's take this scenario, right? So for example we can use we can pick the rail tracks, right? We realize that in the daytime, as a result of heat, conduction takes place, and then when the rail tracks conduct heat, they expand. So therefore, when rail tracks are expanded, it takes a longer time for a train to arrive at its destination. Whereas in the evening time, when the sun is down, the rail track, since it's already metal, it contracts. Therefore, a train arriving at its destination is going to be shorter and quicker. So when we compare these two in relation to the data path cycle, when a data path cycle is longer, it's not many instructions can be executed. But when it is shorter, parallelism can take place, whereby data or instructions can be executed multiple times. I take it again. With looking or assuming or let's use, I take it again. We're using rail tracks as an example. whereby road traffic as an example, whereby in the daytime it takes longer for a train to reach its destination because because um because because the sun shines. Therefore the road tracks conduct the sun rays and then lets it expand, so therefore destination is being stretched. But in the evening time when the sun is down, since there's no heat for expansion to occur, the road tracks contract, making destination arrival very shorter. That is the same way to the data path cycle. However, when the data path cycle is longer, only few instructions can be executed at a time. But when it is shorter, multiple executions can be carried out. So this in relation to pipelining is, we are saying that the data path cycle affects the performance of the CPU, whereby the deeper the pipeline, the more executions can be carried out. But when the pipeline is not deep, or when it is shallow, or the shallower the pipeline, a few executions can be executed. So the pipeline is rather the opposite of the normal one, whereby when it's longer, only few can be executed, and when it's shorter, more can be executed. But however, in the pipeline, when it's deeper, more can be executed, but when it's shallow, only a few can be executed. That's it with how the data path affects the performance of the CPU. Therefore, we can conclude that the CPU being fast, or the performance of the CPU, is mostly affected by the data path cycle. So when a computer system, when the CPU of a computer system, regardless, or putting or making all factors equal, or putting all factors such as the computer's specs aside, when its data path is longer, or when its data path is deeper, only a few executions can be made. But when the data path is shorter and when the data path is very deep, it means that more executions or more instructions can be carried out or executed within a computer system. So all these come together to make us understand, or to make us understand the functionality and the operationality of your CPU's performance based on the computer path, based on the data path cycle of the computer system. Thank you, Group 9, once again, and I hope you really enjoyed and understood this video. Thank you very much.